everybody, and welcome to Big Jet TV. I'm Jerry.
I'm Johnny.
And we are at GE Aviation Wales. Welcome to Big Jet TV. I'm Jerry Dyer.
Johnny Heather.
We are here today at GE Aviation's facility here in Cardiff, Wales, UK.
This is one of the largest aviation maintenance facilities in the entire world, where they service, repair and test their engines. And we'll be having a look at that a little bit later today in the show.
And we will be focusing on the GE90 program here today, guys. Getting up close with the engines, chatting with line engineers and specialists.
And for the conclusion of today's show, we're going to be moving to the test cell, where we're going to see a GE90 115B engine test.
Indeed. So I think the first thing we're going to be doing, Johnny, is you're going to be heading up to the repair shops.
That's correct.
And meeting up with Sam a little bit later on.
You got it.
I'm going to be moving into the borescope section, where they initially receive the engines and go through the initial inspection procedure with Sam. So we're going to go in there and meet the guys, and we'll catch up with you in a little bit. So welcome back, everybody. We are down at the engine receipt area, where we're meeting up with our gate leaders for the day. We've got Jared. Hi, Jared. How you doing?
Hi, Jerry. Good, thanks. You?
Yeah, fine. Thank you very much. And we've got Sam.
Hello.
Sam, so you guys are gate leaders. Just to explain a little bit about what you do, Jared.
Yep, so my role is the Gate 3 sub-assembly gate leader. So I'm responsible for kitting and sub-assembly and providing the modules to the final assembly area.
Okay, so we'll be meeting up with you a little bit later on in that sub-assembly area, and coming back down here to the test area as well.
That's right, yeah.
Okay, thanks very much. And Sam, tell us a little bit about what you do.
Yeah, so I'm the gate leader for inspection. So I manage a team of aircraft engineers who inspect the engine parts once they've been removed from the engine, cleaned and non-destructive tested.
Wow, some interesting stuff that we're going to be seeing in a little bit. So, Jared, we'll catch up with you in a little bit, and I believe, Sam, you're going to show us around this initial area where they borescope the engines.
Yes, that's correct. The borescope gives us an idea of any obvious findings, so that we know before we start to take the engine apart what level we need to. It's not uncommon for us to find more damage within the engine once we expose parts of the modules.
So can we take a little bit of a closer look at one of these engines then,
Yeah,
Sam?
Sure. So this engine just here, this
Yes.
has only just come in. As you can see, it's still in an engine stand. It hasn't really been touched from our perspective just yet. This engine just behind you here, we've loaded into pedestals.
Okay.
So if we have a wander over, I can talk you through the overall structure. So I mentioned earlier on, we take the engine off the engine stand when we're ready to borescope it and load it into pedestals. This is an engine pedestal.
Yes.
They can attach to various different parts of the engine depending on what stage of build or what level of construction we're at with the engine. So each of the modules that gets borescoped has a number of borescope ports.
I see, yes.
So we will remove borescope plugs which plug the ports depending on which stage we need to borescope.
Okay, very interesting. Now, when you talk about modules,
Yeah.
you're talking about the initial compression modules. Or are you talking about what is a module?
So you can think of a whole G90 engine as a series of much smaller sub-engines, if you like.
Yes.
So starting from the front end, you've got the low-pressure compressor module. So that's where the air is first inducted into the core. You then have the fan hub frame, which is what supports the major fan case, goes around the fan blades. Coming further into the engine, you have the compressor, which is the high compression stage, followed by what is colloquially known as the hot section or the combustor. You then have the high-pressure turbine, and then the low-pressure turbine, which is where the hot air exits from the back end of the core. This is where we see the majority of service-related wear.
I see,
So,
yes.
you could almost think about it in the same way that you have to replace the tyres on your car or
Yes.
a belt in your engine
Yes.
every now and again. That happens more often in the hot section than it does in what we know as the cold section, which is anywhere up to the end of the high-pressure compressor. The actual exhaust there itself comes out of this part around here. So when you're looking at an engine on wing and you see an exhaust cone on the back, the pointy bit, that goes on this flange here. So the exhaust there is guided out along the cone and into a stream.
So we are now going to be heading up into the dismantling section where you are specialist in your area, I believe.
That's where we take the engines apart into first the modules that I just talked about and then into piece parts.
Okay, well, we'll catch up with you there in a little bit. So, welcome back. We are in the Gate 1 section. Is that right, Sam?
Yeah, that's correct. So this door just behind us here is where we bring the engines in to the strip area. So once they've been through health checks where we were earlier on, they come into a bay just like this one here. So this bay just here is ready to receive an engine, or it's actually just had an engine leave. So you can see the pedestals are still in place, the brackets are still on the pedestals. Okay, so once the engine is loaded into a bay, it looks pretty similar to how we saw it earlier on in the health checks area where they were boroscoping. The first part of the strip process is removal of all of the electrical components. They're the first accessible things, so you've got things like the fire wires and any electrical units, actuators and things like that. This engine has just finished electrical strip, so we're now just starting with the mechanical part of the strip process. The first thing that we'll take off will be all of the line replacement units. So line replacement units are units like gearboxes, hydraulic pumps, filters, everything that's designed to be changed during service when the engine is on wing. So it's the first thing that you access. It's right in front of you when you lift the cowls up. So this tubular structure running right across the top of the engine here, this is designed to support the weight of the front of the core. So you have two mounts on a G90 engine. You've got the aft mount, which sits right at the back of the engine, and you have the forward mount, which sits on the top of the fan case, which isn't installed here. Those are the 2 points that the engine is mounted to the pylon on wing. And these tubular structures are designed to support the weight of the front of the core whilst the engine is mounted. The next stage is to turn the engine into a vertical position. So that's what we're looking at right here. So you've got the high pressure turbine on the top of what we're looking at here. So turbine center frame, the rotor will be just inside this section here. You've got the combustion chamber with the fuel nozzles removed at this point. So the green taping is to make sure that we don't have any objects going inside the engine. Further down then you've got the start of the high pressure compressor. Down the bottom here you can see the VSV or variable stator vane actuation rings, which I mentioned earlier on when we were looking at a built-up engine in health checks. And then in the pit there, which you can't see right now, you've got the fan hub frame and the low pressure compressor. The pit enables us to move the core up and down depending on what area we're stripping. So right now we're at the point where we're going to remove the high pressure turbine. So this flange just here where all the bolts have been taken out, this flange will be split. We'll lift the high pressure turbine off, and then we'll be left with something that looks like just here in a lobster pot, we call it, or an M40 support stand. So the way that we now refer technically to what's remaining is as an M40.
I see.
That's the 40 module, if you like. On the 40 module, you have the high pressure compressor, which you can see right at the top there, the fan hub frame, and the low pressure compressor. So if you were going to see this on wing, you'd see the fan blades installed on that disc just there. So if we have a wander over, this is our second pit. We have 2 pits in the bulk strip area. This is in almost exactly the same configuration as the one that we looked at just now in the other pit, but this pit is lowered much further because we're currently at the stage that we're releasing some nuts on the what's known as the CDP flange, which is quite deep inside the engine now. It's between the compressor and the high pressure turbine. We have some very, very technical tooling which goes right into the engine through the turbine centre.
So what is the total time on average for a breakdown of the engine?
To turn an engine from what we saw earlier in the engine receipt area to its mini module is generally around about 4 days.
Thanks for that, Sam. We will see you in the next section, but before we head over there, we just wanted to show you guys this little section that GE Aviation have done themselves about women in STEM. And this is science, technology, engineering and maths. So check it out.
I overhaul the most popular commercial aircraft engine in the world.
I'm a technical support engineer at GE Aviation Wales.
I am also a technical support engineer at GE Aviation Wales.
I train and develop engineers of the future.
I'm an aircraft engineer for GE Aviation Wales.
I source material for the component repair shop.
I'm a finance analyst for the world's most popular jet engine.
I'm trained to become an aircraft engineer at GE Aviation Wales.
I'm an environmental health and safety specialist at GE Aviation Wales.
Every 2 seconds a GE powered aircraft takes off and I get to work on those engines.
I apply and develop digital processes for GE Aviation Wales.
I overhaul, maintain and repair aircraft engines for over 90 customers worldwide.
I'm an engineer, and I was the first female managing director of GE Aviation Wales.
We are up in the cleaning bays now, Sam. A number of different bays I can see here.
Right now we're in the tank cleaning area. So what you can see around us are various different chemicals at various different temperatures. Depending on what part we have and what material we need to remove, it depends on which tank we place the part in.
We are into final assembly now, and I'm handing over to my esteemed colleague Johnny.
Hi Jerry, how's it going?
Very well, thanks. It was we've had a long run in there, and this is all over to you now. We're going to be handing over to you and Jared.
Absolutely. So a fantastic show so far. We've seen a lot of things already, got a great insight, and now we're going to finish up at the subsection, Jared.
Yep, that's correct. So what we've got is, here's the kitting area. Once all the material for the engines have accumulated, the parts will come into a technical kitting. And once the kitting has been complete, the modules will then be released to the sub-assembly section. So we'll go through now.
We'll make our way there right now.
So what we have is that we have the stage 2 nozzle, which is on build. The guys are waxing and splining the nozzles, ready then to fit into the stage 2 nozzle. So here then we have the TCF on build. So once the engine is accumulated, from technical kitting through to a complete engine going down to test, we will say 15 days.
And will this particular unit be going in for engine testing a little bit later on in the week or month?
Yeah, later on in the week, this engine will be going down to test, and we'll have its
brilliant.
Full test.
And we'll obviously be seeing something like that a little bit later.
So what we have then between grade 2 and grade 3, and we've keep the area clear at all times, is that the engine stand will come in. The guys will pick the engine up. And we'll then drop the engine into the stand within this area.
Okay.
Once the engine is loaded into the stand, the big folks will collect the engine, load it onto the lorry, and then we'll send it down to the test cell.
So that's been absolutely fantastic, Jared. Thanks for that. And I think we're now going to go and have a look at an actual test of a GE90 115B.
So welcome back. We are in the test cell now. I'm just about to go and meet up with Johnny before we head up into the operations room. But before we do that, just have a look at this. When we met up with Dan, one of the engineers here in the test cell area, who showed us the link-up procedure for the GE90 and how they move it into the test cell. So just have a look at this and we'll be back with you in just a minute. So Dan, thanks for joining us.
No worries.
We're just in this process now of the engine being hoisted up, ready to go into the test cell. Tell us a little bit about that.
Okay, so basically the engine is now ready for test. So what you can see here is the engine being lifted up by the hoist, and we're basically just going to bring it out onto the bridge, take the bridge over, and then basically back the engine into the test bed.
Has the engine been filled with oil yet at this stage?
The engine's completely dry. Once we've linked it to the test bed, we'll start filling it with oils, and we'll then connect the fuel.
Working around these huge engines all day, you must have to pinch yourself.
But yeah, I put literally, to think this engine is going on a 777. I work with the GP7000, which is on the biggest civil aircraft in the world. It's just, yes, unbelievable. Got to pinch yourself some days.
So welcome back, and thanks for that information earlier on, Dan. Johnny, we were talking about these doors earlier on. You had an important stat.
Yeah, I mean, it's pretty crazy. These doors here, they're pretty large, but I've just heard from Jared that these doors are large enough to fit the 777 GE9X engine through these doors here. If they weren't, they'd be knocking down that side panel. But apparently that is actually in the design phase of the engine itself. So take into account the size of these doors in the actual design phase of the GE9X engine.
Okay, we are now going to head into the test area,
yes.
Right into the test bay itself, into the control room. We've got Jared waiting back up there with us.
He is indeed.
So we're going to check that out now. So here we are in the control room. With Jared as well, so obviously see the monitors there, Jared.
Yeah.
What stage are we at with the engine test right now?
We're literally just at the start, and the guys are just about to start the engine on test. So what we'll do, we'll just take a quick visit in whilst the engine's on idle, and we'll come back out and we'll start the test of the engine.
So, this is a sort of first time view from this position here. We're about to head out into the actual test cell itself. Wow. So just to reiterate, guys, this is a GE90 115B. Jared, how long will they run the test for?
The test will be roughly run for about 8 hours, pending no issues then.
So that goes out into the atmosphere, and
so it'll go through, and then it'll just come up out to the top of the test cell.
Where is the fuel located that powers these tests?
Yeah, so we've just got it right at the top, where you can see just at the top of the fixture, fuel will all be coming through.
So that comes from a remote tank.
Correct.
And that's pumped from a remote tank on site, straight through into here.
So
of course all your electrics are linked up as well.
Yep.
So she's basically ready to roll, and that control panel that you have in there is the equivalent of a cockpit control panel.
Correct, yes.
With the throttle assembly.
Yep, I'm ready to start the test.
Let's go and do it.
Let's have a look.
Okay, what we're going to do now, we're going to start the engine. We'll run it min-idle for 5 minutes, and then we'll carry out an acceleration check, which is ground idle to take off in a 1 second throttle movement. After that, the next part of the process is we'll check the oil filters and the magnetic chip detectors, and then we'll carry out the final check of the engine.
So the engineers now are taking down some information and recording it as the test goes on.
Yeah. Which they'll do throughout the testing of the engine.
And that will continue for how long?
Roughly around 8 hours.
Okay, so thanks again, Jared, for today. We really appreciate all your time today, showing us around, both you and Sam. Been very helpful, very enlightening, would you say, Johnny?
Absolutely. I mean, it's just been a great insight into how GE go about their business, and I think our viewers are very happy with how you've helped us understand everything that's going on here.
Indeed. Thanks very much for your time.
Thank you.
Thanks a lot. Cheers. I'll tell you what, Jerry, I'm never going to look at an engine the same again.
Well, I think I'm with you there, Johnny. Every time we see a GP7200 or a GE90 or a 115B, we're always going to remember coming down here to General Electric.
Absolutely.